This is Learning Assessment Problem 11-2. The problem-solving strategy here is that of three-phase balanced AC power circuits. In the problem statement, we are told that we have a balanced Y voltage source with a standard ABC phase sequence. The VAB line-to-line voltage in this three-phase system has a value of 208 at an angle of 0 degrees volts. We are to determine the phase voltages of the source. This would be the VAN, the VBN, and the VCN. Since the system is balanced, we know that the VAB, for instance, is equal to 208 at an angle of 0 degrees volts, and the other two line-to-line voltages will be separated by a phase shift of 120 degrees from VAB, and the same will be true for the phase voltages. The VAN, VBN, and VCN will all be shifted by 120 degrees with respect to each other. The relationship for the phase voltage is that it is equal to the line voltage divided by the square root of 3 and shifted negatively by 30 degrees. So for our current situation, we would have that VAN is equal to the VAB divided by the square root of 3 and shifted by that negative 30 degrees. This would equal 208 volts at an angle of 0 degrees minus 30 degrees divided by the square root of 3, and this is equal to 120 at an angle of minus 30 degrees volts RMS. Then similarly, we would say that VBN is equal to the 208 volts divided by the square root of 3 at an angle of minus 120 degrees minus 30 degrees, and that would equal 120 at an angle of minus 150 degrees volts RMS. And finally, the C phase voltage VCN would be 120 at an angle of minus 240 degrees minus the 30 degree shift in the reference for the line-to-line voltage, and this would equal 120 at an angle of minus 270 degrees volts RMS. This would also be represented as 120 at an angle of plus 90 degrees volts.